All right, this is problem number 8 from our sample problems to get ready for test 3. So it says during a close flyby, the Cassini spacecraft yielded some new estimates of the mass of Enceladus. Remember, Enceladus is one of the moons of Saturn, to be 1.08 times 10 to the 23rd grams. Given that Enceladus has a diameter um, of 499 kilometers, calculate the density. All right. What does this density suggest about Enceladus's composition? All right. So is it closer to ice, which is 1 gram per cubic centimeter, or is it closer to rock, which is roughly 3 grams per cubic centimeter? All right. So one of this, we have to use the volume equation, which says the volume is 4 times pi divided by 3. Right, this is on the sample problems, by the way, times the radius to the 3rd power. And the radius has to be in centimeters, so that's the key here. All right. So we have the diameter of Enceladus. They give us the diameter. So the radius, of course, is just half the diameter. Radius is going to be it's going to be 499 kilometers divided by 2. All right. So now that converts it into kilometers, but I want to remind everybody we need to change it to centimeters. So the way that we do that, of course, is 1 kilometer is 100 meters. I'm sorry, 1,000 meters, 10 to the 3rd meters, and then, oops, that's supposed to go in, and then in 1 meter there are 100, or 10 to the 2nd centimeters, right? So in other words, we're going to take whatever this number turns out to be. Where's my here? So whatever here. Let me just do it. All right. So here's my calculator. All right. So it's going to be 499 divided by 2. All right. So it's going to be 249.5. And see, this is times 10 to the 3rd times 10 to the 2nd, or another way of saying that is 249 times 10 to the 5th, right? So this is here, let me just write this. This is 249 times 10. Geez, I forgot. Hold on, I forgot something. 249.5. Sorry about that. 249.5. That's 0.5 times 10 to the 5th centimeters. All right. So that's what we're going to keep. So we're going to use this number. We're going to use this number right here, and we're going to plug that in for R. All right. So here, let's do this on our calculator. Okay. So here, let me just rewrite it. So it's 249.5 and then exp to the 5th. And now we have to raise that to the 3rd power. All right. So with this calculator, you go x to the y and then raise it to the 3rd. All right. So, and then multiply by 4 pi times 4 times pi divided by 3. All right, there we go. All right, so that's, this is not very nice because it's not in scientific notation, but you get the idea, right? So the volume here, let me see if I can figure this out. All right, so there's, I really hate this calculator. I know I've said that before, but so let's see, 1, 2, 3, there's 6, there's 6, 12, 18, did I count that right? So you start down yourself. So there's 6, 12, 15, 18, 21. So so it's roughly, so the volume turns out to be roughly 6, Here, I'll write this. So that's going to go right here. So 6.5, 6.5. I mean, I'm going to use the unrounded version, times 10 to the 23rd centimeters cubed. All right, so that's all right. Or no, is that 22nd? Sorry, I think it's 22nd. I think I counted wrong. Sorry about that. So let's see. What is this again? I'm spending way too much time on this. All right. Anyhow, so we take this one. So this is probably time to the 22nd. All right. So just to let you know. All right. So anyhow, I mean, it's in the calculator, whatever it is. So take this number, 1.08 times 10 to the 23rd, divided by this number that's in the calculator. So I'm gonna store that. All right, so MS. Let's see that now it's stored. We're gonna watch if I hit recall. See, there it is. All right, so here we go. So it's going to be 1.08 times 10. Where's the EXP? 10 to the 23rd divided by memory recall equals. All right, so the density is 1.66. I think it says to round it to one. Yeah, there it is. One place past the decimal. So the answer would be 1.7. The answer would be 1.7 grams per centimeter cubed. All right, so it's closer to water than it is to well, it's kind of, I don't know. I guess it's kind of in the middle, a little bit closer to water than it is to rock. All right, let's do the next problem. All right, so this one says, what is the gravity? And I put, notice in quotation marks, surface, because there's no surface on Neptune. What is the gravity at the tops of the clouds? That's really what we're asking. So it's going to depend on the mass of I don't know what did I say? I meant to say Neptune. If I think I said Mercury. Anyhow, it depends on the mass of Neptune and, of course, the size of Neptune, the radius of Neptune. Now, the radius has to be in meters, but that's easy to change, right? So here's the radius. R is equal to 24,764, kilometers. And we know that in 1 kilometer, there are 10 to the third meters, right? So the kilometer part cancel. And so that's, this is really easy if you just plug everything in here now. So the acceleration due to gravity at the tops of the clouds is going to be big G, which is always the same number, 6.67 times 10 to the minus 11th times the mass of Neptune, which is 1.02 times 10 to the 26th kilograms divided by 24,764 times 10 to the third. Right, but remember, we got to square that. Okay, so we got to square that. All right, so that's square. All right, so here we go. Here, let's do this one. All right, here's the last problem. All right, clear. Okay, so here we go. It is going to be, all right, so 6.67 times 10 to the minus 11th. Well, I didn't do that right. It didn't do what I wanted it to do. 6.67 EXP to the minus 11th equals. Oh, come on. Oh, geez, I knew what I did. Sorry, I was hitting the minus. You got to hit the plus minus button, okay, for negative sign. 6.67 times 10 to the minus. Oh, there we go. Minus 11th. All right, so that's this. and then multiply it times the mass of Neptune. All right, so times 1.02 times 10 to the 26th, and then divided by, so we're going to divide by this number squared. So it's going to be 24764 times 10 to the third, but I've got to square that. Okay, so if I hit this x squared, that'll square it, and then equals. All right, so that's so remember, just as a reminder, on the Earth, the surface gravity. Now, this is not the surface. This is at the tops of the clouds of Neptune. But the gravity. So on Earth, it's 9.8 at the surface. For the tops of the clouds at Neptune, it would be. Let's see. We're going to round it to. We're going to round it to one place past the decimal. So it would be 11.1, right? Because it's 11.09, and of course the answer is in meters per second squared. So that's the correct answer for number which one is this? I think this is number 9. Hold on, let me take a quick look. Yeah, that was number 9. All right, so number 10. All right, so number 10 here. Let's do this one. All right, here, let me pause it. All right, the speed at which a meteor hits the atmosphere is roughly the speed, in this case, of Mars in its orbit around the sun. So you might say that Mars hits the meteoroid. Remember, meteoroid just means it's something in space. It could be like a little dust particle. That's fine. What is the speed of Mars in its orbit? That's the answer. That's the thing that we're looking for. So we express our answer in kilometers per second, round to one place past the decimal. All right. So we're going to use the average distance that Mars is from the sun as 1.52 astronomical units. So R has to. So this is the idea. The velocity is going to be 2 pi times the radius. Why is that? Because that's the circumference. That's the distance that Mars has to travel in its almost circular orbit, and the period has to be turned into seconds. Right? So we don't know the period, but we know the semi-major axis. Right? That's what this is called. So we can solve that, or we can use Kepler's third law to figure out the period. All right. So it's going to be the square root of 1.5. Oops, I think I just messed that up. All right, so 1.52 raised to the, so you have to hit this x to the y, raised to the third equals, and then take the square root of that. So this is 1.87. So that's what goes right here. So it takes Mars 1.87 years to go around the sun. So the years cancel. That turns it, you multiply that by 365.24 with the number of days in a year. By the way, it's 365.2422 if you wanted to be absolutely exact, but this is more than sufficient. So we got to multiply this times 365.22. Oops, 2.24, sorry. Let me pause this. All right, so when I do all this multiplication, this is the number of seconds that I get. Looks like 59 million seconds, something like that. All right, so I'm going to store that I'm going to hit memory storage. All right, and then we're going to divide by that. All right, so I'm going to figure out now 2 pi times the radius. All right, so I got to multiply 1.52 times the distance of 1 AU. And so this is what I get for the R. 24.2 is the correct answer. 24.2 kilometers per second.